Pump as an integrator and a differentiator. Let me just show you the experimental board.
Back వస్తుందా ఫ్రంట్ కెమెరా
Yeah, this is the experimental setup as you can see. One second. So this is the board. You have a small IC here. This small IC is an operational amplifier having 4 pins, and you can see on the input side you have a resistor and on the output side you have a capacitor. So this particular combination is an integrator. If you interchange, it will be a differentiator. Let me show you what are the connections. Let me show you the connections. I have already connected, but I will show you once. So this is a function generator. This is a function generator. This is used to generate square wave, a sine wave and a triangular wave. So as is the notation, red is always positive and black is negative. And before you start the experiment, connect your CRO cable. Connect your CRO cable directly. If you hold this, you can see it is changing. So this is a positive always. The one you hold, it is not changing, and hence this is negative. So connect the negative here and positive over here, and make sure that you get a proper square wave. Adjust the intensity, the focus to get a proper waveform. Once you are sure that it is a square wave, that is the input that is expected to be given, then leave the connection as it is to the input, and then you have here op amp having 2 terminals, the minus and the plus. Minus is called the inverting terminal, plus is called the non-inverting terminal. And we are using op amp as an inverting integrator. So whenever there is a gap in electronics, that means there's an absence of connection, join them together. And since it is an inverting amplifier, what we have to do is connect the positive terminal, that is the non-inverting terminal, to the ground. So this completes the input section. And you need input, a resistor, and if the output is a capacitor, then that should be your feedback component connected between the input terminal and the output terminal. So this is your output terminal. So this completes the connection, and make sure that you get the input what we've adjusted for, that is the square wave. You should handle these wires carefully. Check whatever you have said is coming. You are able to see the input square wave. So to this, now having been connected, check the output. So once again, this is your positive and this is your negative. You can see a square wave. This triangular wave. This is your triangular wave. So as you change the input frequency, you can see there is a change. So the tabulation would be measure the output frequency divided by the input frequency. It should remain constant, and it tells you how many times it is differentiated or integrated. So the effect of frequency is one aspect that we are studying. Different frequencies, 4 to 5 ranges you can take, and change the capacitance. Now we have taken 0.1 microfarad, replace it with 0.01 microfarad. See, the shape is changed, so that means this frequency is not suitable for this. So since it is 0.01, maybe we must go to a little higher frequency. Yeah. So now it's coming, that was coming in the 1K range earlier, now it's going to the 10K range. So this is the effect of, in each case study the effect of frequency, then go to the different capacitor value, repeat this procedure. Now, so for SOB, this is how your integrator differentiators are working. Then what you have to do is replace this capacitor and interchange them. So what you simply do is, this is the connection, right? Where is this connection going? This is going to the positive. So just replace this. So your capacitor now becomes input, your resistance now becomes the output or the feedback resistor, and see what the effect you are getting. Okay, so let me start again. You have a provision to change the capacitance, the effect of capacitance. So you have to see which range is convenient for this. So let's see, more amplitude. You have to just adjust that. So you can see a differentiated output here. So you can get it here. Adjust this, adjust the amplitude. Okay. Let me try a different capacitor and come back to it. Let it out like